Sathyabama Institute of Science and Technology.
Myself, Gayathri Sivakumar at Sathyabama Institute of Science and Technology, deemed to be university. I'm back again with another interesting topic, that is first come first serve, that is FCFS CPU scheduling algorithm. Without any further delay, let's dive into the content. So this is all about a CPU scheduling algorithm. What is a CPU scheduling algorithm is? It is a mechanism which allows a process to use the CPU scheduling while the another process will wait till the CPU completes because of the unavailability of resources like your input, output, etc. And here is the needs for CPU scheduling algorithm. The first need is when a process is getting into the CPU, the process must wait till it completes, only then the next process can get into that CPU. And here is, in case any of the process is not getting into the CPU for execution, it ensures that when a CPU remains idle, that is, if none of the process is getting into the CPU, if it ensures it the CPU is idle, then the OS will automatically select at least one process to execution. This is the compact or the need of the CPU scheduling algorithm. So here we have some of the important technologies used in the CPU scheduling algorithm. The first is my burst time. Burst time is nothing but the time required by a process for executing this CPU. And the next is my arrival time. Arrival time is nothing but if a process is there, the time at which the process arrives in the ready queue is called as my arrival time. And the next is my completion time. Completion time is nothing but the time required by a process to complete its entire CPU execution is called as a completion time. And the next is my turnaround time. Turnaround time is the difference which has been calculated from the completion time and the arrival time. The formula for this turnaround time is difference will be calculated with the symbol minus. So my turnaround time is equals to completion time minus the arrival time. And the last important is my waiting time. Waiting time is the time difference between the turnaround time and the burst time. That is, turnaround time minus my burst time is the waiting time. So here is a process. This process plays a major role for this CPU scheduling algorithm. It is a major source of our scheduling. The first is, process is nothing but a program in execution. For example, a current program which has been executed right now by using one or more threads is called as a process. In simple, this process can also be called as PCB, that is my process control block, where this PCB is the information that is stored by all the processes that can be like your state of a process or the location of a process, etc. And here, when a process scheduler schedules a different processes, that processes will be assigned to the CPU by different scheduling algorithms. We have several scheduling algorithms like FCFS, that is your first come first serve, next is shortest job first, and shortest remaining job first, priority queue, and lots of them. So here is the major important state of a process. The first one is my new. New is nothing but it is initial state of the process which has been created. And from here the process will be ready to move to the ready queue. Ready is nothing but a process is ready in the queue to assign a processor, and it waits for the OS to allocate those processes. And from ready it is going to go to the running state. Running state is nothing but here once all the processes has been assigned from the ready state to the running state. Once all that has been assigned, the process will enters into the running state and executes all the instructions. Okay, and from running state, here I have some input and output wait. From there it is moving to my waiting state, where if at all any process occupied by the resources which has been used by some other process, then that running process, this running process must wait in a waiting state once that process completes. Only then that process from the running state can move to the waiting state. And from here all the process has been gone, and out the input and output completion is moving to the ready state. From here it is going to the termination. Terminated is nothing but it is an exit, also called as exit. So this termination is nothing but once the complete execution is completed, the OS will terminate the process which has been finish the execution, it will remove out from the main memory. This is how the process of state is going to work. Here we have two types of scheduling algorithm. The first is preemptive and the next is non-preemptive scheduling. Preemptive scheduling is nothing but it is a process which switches from the running state to the ready state, or you can also say it as a process that switches from the waiting state to the running state. See, for example, if a process is going on with execution of a CPU only for a particular or some certain amount of time, this preemptive scheduling processes can occupy the execution. And the next is, if a process is running in the CPU, then that particular process will be forcefully moved. It will be forcefully moved by the CPU, and the CPU will occupy some other resources. That is called as my preemptive scheduling algorithm. And the next is non-preemptive. It is complete opposite of my preemptive, where here the process is going to switch from the running state to the waiting state. It is going to switch from the running to the waiting state is called as my non-preemptive scheduling. And here the CPU which has been allocated with the process, it waits till the complete execution is done. But here you can see only for some certain amount of time it will stay, but here till it completes its execution it is going to stay. And the next is, if a process is running in the CPU, then that process must wait till it gets terminated. That is, till it moves to the last state of a process. This process must be waiting in the CPU to complete its complete execution. So this is all about my FCFS. FCFS is nothing but the acronym is first come first serve. This is also called as first in first out. And here the information or the definition is, it states that when a process is requesting, for example, if any process is requesting to the CPU first, the process which gives the request first will be allocated with the CPU first. That is implemented by first in first out queue. See, for example, if we have 5 processes, if P1 is giving the request first, then that process will move to the CPU for completing the execution. Once it's completed, remaining process will be in the waiting state. It is all about the FCFS. So the process will be executing in the linear manner, that is called as the linear order. So here it is a non-preemptive. As we told, there are 2 types. Among that, this FCFS comes to the category of non-preemptive scheduling, where the CPU will wait till the process completes its entire execution. So FCFS is a convo effect. This is a major important point or a terminology, where convo effect is nothing but if any of the process is with higher burst time, if that comes to the first, but the process with lower burst time is moving on to the last, but the process with a lower burst time will wait for longer amount of time till the process with the higher burst time completes or the CPU releases that process. That is called as my convo effect. Here I have given a real-time example. So, for example, you are going for a shopping that can be both online or offline. Okay, so if it is like offline, if you are going and standing in a queue, the one who comes at the first only giving the cash and getting the bill and the products. Even in online delivery also, the products which you purchase or buy first will be coming on the time first, and later based upon the delivery you do, you are going to. So here is a real-time example for first come first serve. And now we are going to solve with an example problem related to FCFS. Here consider I have a 5 set of processes P1, P2, P3, P4 and P5, and whose arrival time and the burst time is given, and I need to calculate average waiting time and the average turnaround time. So this is called as my Gantt chart. Gantt chart is nothing but a pictorial representation. It shows when does the process enters into the CPU and when does it completes execution. So this is called as my Gantt chart. So now first looking on to the process, see which process is having the least or which process comes in FCFS, that is which process comes first. Say 0. So 0 is occupied by the process P3. So my P3 will be the process which comes in the first with a arrival time of 0. Now for this process P3, my arrival time is 3. And what is my burst time? It is 3. So this is going to be the process is going to start, the CPU will reach at the time unit of 0 and it will complete at the unit of time 3. Okay, now after 0, do you have any other greater number than next to 0, like 1, 2? No, it is not this. So this blank space is called as my idle time. So here it will be blank where my CPU remains idle. Remains idle since I have no other process next to 0. And moving on to the next process, here I have 3. Now after 3, you just check which is the next number after 3 is 4. You can find a 4 which is occupied by the process P1. So now my P1 is going to occupy the next position. So P1 is occupied with the arrival time of 4 and the burst time of this P1 is 5. So now 4 plus 5 is equals to 9. So my process P1 will start at the unit time of 4 and it will complete its execution at the unit time of 9. Okay, now it is starting with the number 4. So now what is the next number which is greater than 4 is obviously a 5 which has been occupied by P5 process. The 5 is occupied by the process P5. So now this P5 will move to the next state and see the burst time of this P5 is 4. Now the P1 has already completed its execution at the time 9. So 9 plus 4 is equals to 13. So now my P5 will start with the unit time of 9 and it will complete at the unit time of 13. And now after 5, what is the next number which is higher? Obviously it is 6. But in 6 you have two processes, that is P2 and P4 is there with the same unit of time 6. So among these two, the term FCFS says which comes first. So now for P2 and P3, which process is coming first? P2 is coming with the least amount, like ascending order. So obviously my P2 is going to occupy the next CPU execution. So it starts with the unit time of 13 and for P2 what is the burst time? It is 4. So 13 plus 4 is equals to 17. So P2 will start with the unit time of 13 and it will end with the unit time of 17. And the left out process is nothing but P4 which is going to occupy at the last. And this P4 has a burst time of 2. So this P4 will start with a time of 17 and it will end with a time of plus 2. So it will end with a time of 19. So this is how your Gantt chart is. And now they asked me to calculate the turnaround and the waiting time. As we discussed in the important terminologies I told, just the turnaround time is nothing but the difference. Difference is calculated by minus. So completion time minus the arrival time. So look at here. So here is my process ID P1, P2, P3, P4, P5. And the completion time of P1 is C towards your right. So it starts from the unit of 4 and it ends with the unit time of 9. So my P1 completion time is 1. And the same way for P2, the next process for P2, it starts with a time of 13 and it completes with a time of 17. So for P2, my completion time is 17. Next P3, for P3, the process starts with the time 0 and it completes with the time 3. So for my completion time is going to be 3. And the next process P4, obviously it is starting from 17 unit of time and ends with 19. So my P4 completion. And the last P5, it completes with the completion of time 30 units, 13 units have given. Next is, I need to calculate my completion minus arrival. So completion time is already given, minus the arrival time is given in the question. So 9 minus 4 is my 5 and 17 minus 6 is 11. 5, here is my completion time of P3 is 0. 3 minus 0 is equals to 3 and here is 19 and for P4 the arrival time is 6. So 19 minus 6 is 13 and the next is 13 minus 5 is equals to 8. Okay, this is how you calculate the turnaround time. And the formula for this waiting time is this turnaround time minus the burst time, which has been already given in the question. So now my turnaround time is 5. So 5 minus 5 is obviously 0 and 11 minus 4 is equals to 7. And for P3 here the turnaround time is 3. 3 minus 3 is 0. For P4 it is 13. Minus 2 is equals to 11 and 8 minus 4 is equals to 4. This is how we are going to calculate. But this is just a turnaround time. But I need to calculate my average turnaround time and the average waiting time. So here the formula for averages you all would have known. So it is the total sum divided by the total number of sums you have, right? So the average turnaround time is 5 plus 11 plus 3 plus 13 plus 8 and totally how many processes we have? From P1 to P5, we have 5 processes. So the total sum divided by 5, that is 40 divided by 5, which is equals to 8. So ms stands for milliseconds. This is how we are going to represent. The same way for average waiting time. So 0 plus 7 plus 0 plus 11 plus 4 divided by the total number of processes 5. So 22 by 5, that is equals to 4.4 millisecond. This is how you have to calculate your turnaround and the average waiting time when coming to FCFS CPU scheduling algorithm. Thank you for watching this video. We'll see you all in another interesting topic.